Hello again from Team Titan. My name is Elijah Anakalea Buckley, and I'm the team lead for this project. I'm here along with my teammates Hui Wan and Hao Liu.
I'm Hui Wan and I'm the team recorder.
I'm Hao and I'm the project architect.
Our project is sponsored by research leads Dr. Will Grundy and Dr. Jennifer Hanley of Lowell Observatory, and guided with the help of our team mentor, Vladimir Saruta. So, until recent breakthroughs in technology, the scientific pursuit of understanding the world around us was usually based around our own perspective here on Earth. And through all that time, we have acquired a relatively intimate understanding within Earth's domain. Earth's geology and atmospheric environment come to us as second nature. A blue sky, liquid water, and a surface crust that is carved and molded by an energy-rich climate. But on the astronomical scale, this is actually quite rare. In the Milky Way galaxy alone, there are an estimated 100 billion planets. Of that, it appears less than 3% can be deemed Earth-like.
As for the other planetary bodies in our universe, they experience a range of inhospitable environments, such as that of universe, whose average surface temperature reaches minus 371 degrees Fahrenheit. The farther from a star, the colder and more bizarre the planet's environment becomes. These are the words that our clients are working to better understand. For this project, Team Titan is operating on the core data collection system for Lowell Observatory's Astrophysical lab on new campus. Led by our clients, the researchers at the lab make use of custom-engineered grand chamber which simulates these unbelievable cold temperatures, and their efforts on different surface compounds. For the purpose of our team's involvement in this project, the client's lab system consists of several engineered components: the plexiglass freezing chamber, upper and lower temperature sensors, a temperature controller, pressure regulator, lower heating system, and cooling system.
To make use of this system, Dr. Grandi has designed a Linux computing environment that executes a custom control panel interface which primarily dictates the system's temperature and pressure sensors, monitors and visualizes data received from those sensors. It then stores the collected temperature data into a standard CSV spreadsheet, which itself is stored within a structured folder hierarchy on the file system. On the right, you can see an image taken of the computer interface with both spreadsheet and control panel open. It all operates on a Linux desktop environment. The problem with the current implementation is that it's operating on recently deprecated software libraries. It's also a home-built solution contained in a single Python file that lacks additional nice-to-have functions, like optimized data visualization and plug-and-play lab hardware connections. It has essential functionality and meets short-term goals, but it still leaves much room.
Team Titan will first provide a completely updated version to the current system, rewritten in the most recent Python syntax and the corresponding libraries. This refresh of old system will allow research to be continued, while the team works to further develop new features. The goal is to provide a totally up-to-date basic product, built with a clean modular structure that will allow users, whether it be the lab team or Team Titan, to add and remove features without sacrificing the integrity of the code's core functionality.
To start off the implementation of the solution that is set, We first have the structure and modularity in mind of separable aspects of the system. This will come in the form of separate files and components that will be linked together and work cohesively with each other to produce a product that has longevity and usefulness to the clients. The core of the system will be written in the Python programming language. Some components, such as the user interface as well as the notification system, will be created with branches of Python and utilize libraries such as pyqt to deliver different UI and support components, and SMTP lab that will support some of the alarm system aspects. These libraries will be the tools we use to accomplish the working product as well as modularity. The main two aspects in the project will be the UI folder and the source code folder. The UI folder will be a collection of files and hold all of the UI handling for visual aspects of the program. The source code folder will have multiple files handling the inner workings of the program, including the connectivity, data capturing, backend, alarm system, and other bells and whistles set forth by the client. All files will be separate and commented up extensively. In the case that one file fails, the other will not be affected and the program will still be able to run. The data collecting system is divided into three essential parts: user interface, data logging, and hardware connectivity. User interface is an up-to-date version of a graphical user interface (GUI). The most essential functionality provided by the UI would be real-time line graph data modeling, by which the scale of the graph axis can be manipulated by users from within the UI. That means datasets collected not only can be formed as visual graphs, but also can be stored into a database for further analysis later. There is also an alarm system contained in the user interface, which is introduced specifically in the hardware connectivity module.
Data logging is the most significant functionality in this system, since the users will depend on the data logging to collect data, such as temperature and time period, for research and analysis. Data recovery is necessary in the case the system encounters power failure, network interruption, or devices damage. These data sets can be exported to a usable format, CSV file, in good organization. In this module, many functions will be provided to make it easier to search and do more operations in the data file. Hardware connectivity will build a stable connectivity between different use of devices, such as a device for data collection and another device for data production.
The prototype provided to the client currently has 90% of all functionality that is required. With the prototype handed off to the client, they are able to run experiments and tests with the software while we are implementing the finishing touches to the system. We will be showcasing a short walkthrough of the system and describing the general use of all aspects. The system consists of three primary files that the user can handle to implement new aspects and functionality. The entire UI that you see here was created using pyqt libraries. These libraries are extremely easy to handle and manipulate, which gives the later developers many opportunities to implement and develop new features. Everything within the opening UI is in the settings file. All objects, placeholders, containers, and placement handlings can be found and managed in a single file. The buttons are very self-explanatory and very similar to the old system. Switching to something radically different would impede on the research done by lab members and grad students, so all buttons and graphs that are found on the old system can be found in our newly updated version. Some of these features include a live plotting graph for the experiments being run, a command line to issue commands to the controllers, as well as histories of said commands. When you connect to the system and hardware, you will see an indication of successful or unsuccessful connection. When running an experiment, you will have seen the data being gathered and plotted onto the graph that is configured. The different colored lines indicate what sensor they are corresponding to and the ability to take away some sensor plots to avoid unnecessary clutter on the graph. For the purpose of consistency in file management and familiarity in data saved, the clients have asked us to replicate the formatting of the previous system's file save functionality. There is no need to save files. Once connected and receiving data from the hardware, a CSV file is automatically made with the current date and familiar headers. The alarm system was somewhat difficult to make and needed relatively complex logic to suit the needs of the clients. Because of this, the alarm system functionality and UI are all contained on a separate file. This is done in preparation to the upgrades to the system that are due within the next year. The UI for the alarm is extremely easy to manage and change, while the logic is contained in the same file. The alarm system you see here was created with the input from the clients for very specific monitoring capabilities and common defaults for the alarms. Unlike the old systems, the alarms that have been created will be seen in the alarm list page. Along with that, the system will now have email functionality so that if the researcher is away from the computer or the system, they will be notified when thresholds have been met. The system created by Team Titan is a completely updated version of the previous system, now running on the most recent Fedora operating system as well as the newest Python version. The students and researchers at the lab will be able to carry out their experiments and handle their findings with a system that has longevity and all capabilities of the old system.
Most of the challenges faced this semester were surrounding the base UI components and the initial connectivity functionality. Learning the UI inner working took some practice and patience, but once you understand the concepts of the PyQt5 libraries, changing and building UI components become much easier. Making successful connections and receiving useful data took some time. Through multiple attempts and some trial and error, we were successful. The last of our challenges that we still need to handle is some of the alarm system logic.
Currently, Team Titan is a little behind schedule of what we were expecting for the system. With the full prototype built, the testing and refinement has already begun and progress is still steady. Majority of the remaining work that needs to be done for the completion of the project are small UI refinement from the input of the lab researchers, as well as presenting and delivering Team Titan's products.
The testing process for the project has already been implemented and seen results. The majority of the tests will be user-based and focused on creating a user experience that is comfortable and reliable for the researchers. Because of the COVID-19 pandemic, testing in the lab on a daily basis is simply not possible. To address this problem, the team and the clients exchange emails daily to settle issues and make bug fixes when they arrive. Because of this open communication, our testing is going as planned and we are currently in the final stages. Overall, the team has made huge strides since our last presentation. The development of the CC tool has been accomplished, refactoring and refinement is in progress, and the team is on track to deliver the product created to the client by the third week of April. Thank you very much for your time and attention. Team Titan,